Imagine, if you will, a giant asteroid barreling towards Earth. Could it be the end of the world as we know it? Now that's a thought to make your heart skip a beat. These celestial nomads, known as asteroids, are remnants from the early solar system. Some are as small as a grain of sand, while others are large enough to cause a global catastrophe. Consider this. An asteroid about 6 miles wide struck Earth 65 million years ago, creating a chain of events that wiped out the dinosaurs. Now, the chances of a similar catastrophe happening in our lifetime might be slim, but it's not zero. The average person is more likely to win the lottery than to see Earth meet its end through an asteroid collision. But the stakes here are not a few $1,000,000. It's the survival of life as we know it. The potential consequences of a doomsday asteroid hitting Earth are, in a word, catastrophic. The immediate impact would trigger massive firestorms and tsunamis, depending on where it strikes. The aftermath would be even worse. The dust and debris thrown up into the atmosphere would block out sunlight, leading to a nuclear winter effect. Crops would fail, ecosystems would collapse, and life would be very, very difficult for those who survived the initial impact. Now, I know what you're thinking. This all sounds very gloomy, but don't despair just yet. While the threat is real, it's not imminent. With every passing day, our understanding of these cosmic wanderers improves. We're getting better at finding them, tracking their paths, and calculating their chances of colliding with Earth. So, how has Earth survived asteroid impacts in the past, and what can we learn from these cosmic encounters? That, my friends, is a story for the next scene. Earth has had a long and tumultuous history with asteroids. Let's delve into the past to understand more. Our journey begins over 4 billion years ago during an era known as the Late Heavy Bombardment. This period was marked by a dramatic increase in asteroid activity, resulting in a rain of cosmic debris that pockmarked our young planet with craters. These early impacts played a significant role in shaping the Earth's surface and possibly even contributed to the formation of life by bringing water and other essential elements to our planet. Fast forward to about 65 million years ago, an asteroid with a diameter of roughly 6 miles plunged into what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of atomic bombs, creating a crater over 100 miles wide. The aftermath of this event, known as the Chicxulub impact, was catastrophic. A cloud of dust and debris enveloped the Earth, blocking out the sun and causing a dramatic drop in global temperatures. This nuclear winter led to the extinction of around 75% of all species on Earth, including the dinosaurs. In more recent history, we have the Tunguska event, which occurred in Siberia in 1908. An asteroid exploded in the atmosphere with the energy of 1,000 Hiroshima bombs, flattening over 800 square miles of forest. Remarkably, there were no recorded human fatalities, but the event served as a stark reminder of the destructive potential of asteroids. Fast forward to 2013, when a relatively small asteroid, about 65 feet in diameter, exploded over Chelyabinsk, Russia. The shockwave injured over 1,000 people and caused significant property damage. This event, like Tunguska, served as a wake-up call, highlighting the need for improved detection and deflection strategies. Despite these notable events, it's important to remember that most asteroid impacts are not doomsday scenarios. Many asteroids burn up in the Earth's atmosphere before they reach the surface, and others land in remote areas or in the oceans, which cover about 70% of the Earth's surface. However, the potential for a catastrophic event, while statistically low, is not zero. As we look to the future, we must also look to the past. The history of asteroid impacts on Earth is a sobering reminder of our vulnerability in the cosmic shooting gallery. But it also offers lessons for how we can prepare and protect our planet. Asteroids have played a significant role in shaping our planet's history, from possibly contributing to the formation of life to causing mass extinctions. They remind us that we are part of a dynamic and ever-changing universe. So we see asteroids have played a significant role in shaping our planet's history, but how are we preparing for future asteroid encounters? In the vastness of space, finding a potential doomsday asteroid is like finding a needle in a haystack, but we're getting better at it every day. Now you might wonder how we go about finding these elusive celestial bodies. The key is a combination of advanced technology and international collaboration. Ground-based telescopes and space-based observatories constantly scan the skies for signs of near-Earth asteroids. These are the ones that could pose a threat to our planet. As they scan, they gather data, which scientists then analyze to calculate the asteroid's size, composition, and trajectory. One notable tool in our asteroid detection arsenal is NASA's NEOWISE mission. This space-based infrared telescope has discovered thousands of asteroids since its launch in 2009. It uses infrared light to detect the heat of asteroids, which can be easier to spot than the reflected sunlight that most telescopes rely on. But technology alone isn't enough. The world's space agencies have to work together to track asteroids accurately and efficiently. This is where the International Asteroid Warning Network comes in. This group of organizations from around the globe coordinates efforts to detect, track, and characterize potential hazardous asteroids. They share information and resources, ensuring that no asteroid goes unnoticed. Once an asteroid is detected, scientists need to determine whether it's a threat. This involves calculating its trajectory to predict whether it will cross paths with Earth. They use complex mathematical models and computer simulations to do this. But it's not an exact science. There's always some level of uncertainty involved. And what if we find an asteroid that's on a collision course with Earth? That's when deflection strategies come into play. There are several proposed methods for deflecting an asteroid, ranging from the simple to the sci-fi. One method is the kinetic impactor technique. This involves smashing a spacecraft into the asteroid at high speed to change its trajectory. NASA's DART mission, launched on November 24, 2021, the DART spacecraft successfully collided with Dimorphos on September 26, 2022, about 11 million kilometers, approximately 6.8 million miles, from Earth. The collision shortened Dimorphos's orbit by 32 minutes, greatly exceeding the predefined success threshold of 73 seconds. DART's success in deflecting Dimorphos was due to the momentum transfer associated with the recoil of the ejected debris, which was substantially larger than that caused by the impact itself. This mission marked a significant milestone as the first ever dedicated investigation and demonstration of one method of asteroid deflection through kinetic impact. Another proposed method is the gravity tractor. This involves parking a spacecraft near an asteroid and using the spacecraft's gravity to slowly pull the asteroid off course. It's a slow process, but it could be effective for smaller asteroids. And then there's the nuclear option. Literally, detonating a nuclear device near an asteroid could potentially deflect it. This is seen as a last resort, though, due to the many potential risks and international treaties prohibiting nuclear explosions in space. While detection is crucial, it's only the first step. What happens when we do find a hazardous asteroid on a collision course with Earth? The answer to that question is a combination of scientific ingenuity, international cooperation, and a dash of daring. The universe may be vast and filled with potential threats, but we're not helpless. We're getting better at protecting our planet every day. Facing down a potential doomsday asteroid, we need more than hope. We need a plan. Let's talk about the strategies and technologies that currently exist to deflect or disrupt a hazardous asteroid. It's like a cosmic game of billiards, but the stakes are much higher. The most straightforward method is a kinetic impactor. Essentially, we're talking about a spacecraft that would crash into the asteroid at high speed, altering its trajectory just enough to make it miss Earth. NASA's Double Asteroid Redirection Test, or DART mission, is a real-world example of this strategy. It's set to collide with the moonlet of a binary asteroid system, in a bid to change its orbital speed by a fraction of a percent. Enough over time to significantly alter its course. Now, what if the asteroid is too large for a kinetic impactor to handle? That's where a gravity tractor comes in. This involves positioning a spacecraft near an asteroid and using the gravitational attraction between the two bodies to slowly but surely pull the asteroid off its Earth-bound course. But wait, there's more. In a situation where we don't have much time, a more drastic measure might be needed. Enter the nuclear option. Not to blow the asteroid to smithereens, which could create a devastating meteor shower, but to detonate a device near the asteroid, vaporizing part of its surface and creating a force that pushes it off course. It's important to note that these are not just theoretical concepts. They are active areas of research and development by space agencies like NASA and the European Space Agency, or ESA. These organizations are working tirelessly to turn these ideas into reality, testing technologies and conducting mission simulations to ensure we're ready if or when the time comes. NASA's Planetary Defense Coordination Office, for instance, is dedicated to the detection, tracking, and characterization of near-Earth objects, while also developing methods for deflecting any that could pose a threat. Meanwhile, ESA's Hera mission, named after the Greek goddess of marriage, is set to rendezvous with the same asteroid system that DART will impact, providing vital data on the effectiveness of the kinetic impactor method. These measures are all part of Earth's cosmic defense strategy, but it's not just about the technology. It's about the people behind it, the scientists, engineers, and researchers who dedicate their lives to safeguarding our planet. It's about ongoing vigilance and relentless innovation. Remember, the goal here isn't to cause mass panic, but to foster understanding and awareness. The threat of a doomsday asteroid isn't just the stuff of science fiction. It's a real, albeit remote, possibility. And as with any potential crisis, the key to survival is preparedness. Our cosmic defense strategy is constantly evolving, but it's not just about the technology. It's about the people behind it. When it comes to defending Earth from asteroids, we're all in this together. Indeed, the vast expanses of space do not recognize national borders, and the threats it houses are indiscriminate in their potential for impact. Thus, the defense against these cosmic hazards is a shared responsibility, a mission that necessitates international collaboration and scientific innovation. Over the years, we've seen a remarkable surge in global cooperation. Space agencies from around the world, including NASA from the United States, ESA from Europe, Roscosmos from Russia, and many others, have come together to pool their resources and expertise. This synergy has led to the conception and execution of numerous joint missions aimed at detecting, tracking, and mitigating the risks posed by asteroids. However, it is not just about pooling resources and sharing data. It's about building on each other's discoveries and pushing the boundaries of what we collectively know and can achieve. This is where scientific innovation plays a crucial role. The rapid advancements in technology have now made it possible to not only detect asteroids with more precision, but also to develop potential strategies for asteroid deflection. Concepts that once belonged to the realm of science fiction, such as using spacecraft to nudge asteroids off their collision course with Earth, are now being seriously considered and even tested. One shining example is the DART mission, a joint venture by NASA and ESA. With the aim to change an asteroid's orbit through kinetic impact, the mission represents a significant leap forward in our cosmic defense capabilities. These strides in scientific innovation, fueled by international collaboration, are our best bet against potential doomsday asteroids. They embody our collective will to protect our home planet and ensure the survival of future generations. So, as we look to the stars, we know that we're not alone. We're all part of the cosmic defense team. The threat of doomsday asteroids is real, but not inevitable. In the grand tapestry of the cosmos, Earth, our beloved blue marble, faces a myriad of threats. Among them, the prospect of a doomsday asteroid strike might seem like a plot straight out of a science fiction film, but it's a very real concern. History bears witness to the devastating power of these celestial bodies. The extinction of the dinosaurs, the Chicxulub impact, stands as a stark reminder of the potential havoc an asteroid can wreak. Yet, we're not helpless against these cosmic bullets. Thanks to cutting-edge technologies, we're now better equipped than ever to detect and deflect potentially hazardous asteroids. Instruments like radar telescopes and infrared sensors are our sentinels, scanning the heavens day and night for any signs of danger. Our Earth's cosmic defense doesn't just rely on technology alone. It's a concerted effort of international collaboration and scientific innovation. Space agencies like NASA and ESA, along with scientists across the globe, are working tirelessly to safeguard our planet. Their commitment to ongoing vigilance is our best defense against any future asteroid threats. Moreover, the world of science is continually evolving. Innovations are being made, theories are being tested, and knowledge is being expanded. This constant pursuit of understanding is the cornerstone of our defense strategy. It's this spirit of curiosity, the desire to reach out into the unknown, that will ultimately keep us safe. In the grand scheme of things, we're just a tiny speck in the universe, but it's our home, and it's worth protecting. The threat of doomsday asteroids is a reminder of our responsibility, not just to ourselves, but to future generations. Stay vigilant, stay curious, and stay tuned for more enlightening content from the Facts Intrigue channel. Don't forget to like, subscribe, and turn on notifications. Until next time, keep looking up.